Welcome to my show, Science Team in Lab 23. I'm your host, Morgan Mack, and this episode is about physics. Now you say, what is physics? Well, here's some examples right now. Newton's first law is an object at rest wants to stay at rest, and an object in motion wants to stay at motion at a constant speed and in a straight line until an unbalanced force is acted upon it. So we have an air hockey puck, and I'll place it on an air hockey table, and it will be at rest and stay at rest till the unbalanced force, which is this, hits it into motion. Now, it will stay in motion until an unbalanced force, which is the wall, and gravity put onto it to put it back into rest. Newton's second law is the acceleration depends on the mass of an object and the amount of force acted on the object. So, I have an 8-pound ball and a ball filled with air. Now when I both put the same amount of force onto them, one was faster accelerating upwards because it was lighter, and the other ball accelerated faster downward because it was heavier, proving Newton's second law. Newton's third law is when one object exerts a force to the second object, so the second object will exert an equal and opposite amount of force to the first. So, our first object is this angry bird, and the second object will be this wall. When I throw the angry bird to the wall, the angry bird hits the wall and bounces off the wall because the angry bird exerted a force to the wall and the wall exerted the force back. Hey, I have a question. What is it? What is kinetic energy? Well, you don't have to shout it at me. I'm sorry, just tell me now. Well, it's energy in motion, and to calculate it, it's mass times velocity squared divided by 2. And what the equals is a joule. Oh, I get it. But I have a different question now. Let me guess, you want to know what potential energy is? Okay, I knew you were a smarty pants, but you're a mind reader too? No, I just knew it was going to be your next question. But potential energy is energy an object has because of its position and shape. And my very last question is mechanical energy. Oh, I already know about that. It's kinetic energy plus potential energy. My last question is, how do you know all? Easy. By studying in Mr. Majetti's classroom. Have you ever ran in a track meet or some sort of race and you really want to know what your speed was? Well, I have an easy solution for you. Do speed equals distance divided by time. To simplify that, we do S equals D divided by T. Your example, say you are running a 200-meter dash, and you ran that in 50 seconds. So, you do 200 divided by 50, and your speed equals 4 meters per second. Now, say you wanted to know how fast you were accelerating through the race. Well, acceleration equals final velocity minus starting velocity divided by time. So, our example, we were doing the race up here, so our final velocity was our speed, 4 meters per second. Since we started the race at the starting line, it would be 0 since we weren't moving. Then, our time was up from here is 50 seconds. So then you do 4 minus 0, which is 4 meters per second, divided by 50, and you get 0.08 meters per second squared as your acceleration. Okay. Now you know how fast your speed was in the race and how fast you were accelerating through the race, but how much force was acting up on you during the race? Well, to calculate that, it's force equals mass times acceleration, or F equals ma. Our examples say that the person was 50 kilograms, and their acceleration is still 0.08 meters per second squared. So you do 50 times 0.08, and then you get your force as 4 newtons, because kilograms times meters per second squares equals a newton. The law of energy conservation is that energy can't be created or destroyed, only transferred to different types of energy. So in the lamp, the battery energy is transferring into electricity energy. When I turn it on, it starts making a clicking sound, so it's sound energy. Then once I turned it fully on, it turns into light energy and heat or thermal energy. When objects fall, all objects fall at the same amount of acceleration, no matter how heavy the object is or how big or small it is. So, when we have a small angry bird and a big smiley face ball, and they fall at the same time, they both hit the ground at the same time, because it doesn't matter how big or small or how much it weighs. But take this thin and flat piece of paper and this angry bird. The angry bird hits the ground first because the piece of paper is flat and thin, and air is affected on it up here, so it floats more. Inertia. Inertia is an object at rest wants to stay at rest, and an object in motion wants to stay in motion. So, to prove this method, I have pencil, and I have a piece of paper. Now I'm going to do an amazing magic trick, where I will make the paper move, but the pencil will stay in place. Ready? Set. Woo! That's inertia. The pencil has so much inertia because it wants to stay at rest, so it stays on the desk while the paper is moving. This segment's about solids, liquids, and gases. So our solid is this phone, our liquid is this cup of water, and our gas is this balloon filled with air. Now a solid is an object that takes up mass. So this phone takes up mass, and its particles inside it are vibrate in place, and there's a lot of them. Our liquid is something that fills up any container, and its particles inside it slide past each other in a medium fast speed. Our gas's particles move really fast, and since there's less of them, it makes it more of a gas and floats. rocks out there. And they have all been made out of these three types of rocks: igneous rock, sedimentary rock, and metamorphic rock. Igneous rock is made from lava or magma that has been cooled. Sedimentary rock is sediments from erosion that are layered to make the type of rock. Metamorphic rock is igneous or sedimentary rock that worked up to the mantle of the earth and has been changed by the heat in the mantle. So all rocks have been made by these three ways. So that would make the rocks what they are now. Thanks for coming to my show. Next time we're going to talk about how cheese was made. Have a good day.